Question number 5, we are going to study first a polynomial and then the rational function using that polynomial as as a numerator. So find all the complex roots. So that's another way to invite you to factor this whole polynomial. And to do so, I'm going to use the rational zero theorem by having p being equal to plus or minus 1, 2, and 4, or the possible multiples of the constant. And I'm going to take the leading coefficient, which is 3. That's going to be q, and I'll have 1 and 3 only. Now, any rational roots will have the form of plus or minus p over q. So the first thing I'm going to do is to list the coefficient of f of x. So I will have 3, negative 1, negative 12, 7, negative 1, negative 12, and 4. And here you can try the different possibilities. So I'll have plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 1 over 2, plus or minus 1 over 4, and so on. Okay? So you try them out. I do not need to see them. So this is why using a scratch paper is essential. So here I'm going to plug in negative 1, and I have 3 plus nothing is 3, negative 3, negative 4, positive 4, negative 8, positive 8, 15, negative 15, negative 16, positive 16, positive 4, negative 4, and 0. I know that I am successful when the remainder is 0, which allows me to apply the factor theorem. Why? Just a little reminder. That means if use that as a synthetic substitution, that f of negative 1 is equal to 0. Therefore, x plus 1 is a factor. So I'm going to use synthetic division slash substitution as a factoring technique by trying out those different possible rational zeros. So next, I'm going to get, so I want to have 0 at the end, and I know that 2 works also. So 3 plus nothing is 3, times 2 is 6. I have minus 4 is 2, 4, negative 4, negative 8, 7, 14, negative 2, negative 4, and 0. The next one, which is going to work, which will also give me 0. The next one, which is going to work, is negative 2. So I have 3, negative 6, negative 4, positive 8, minus 4 is 4, negative 8, negative 1, positive 2, and I have 0 indeed. And finally, the next one will be 1/3. So I have 3 divided by 3 is 1, minus 4 is negative 3, divided by 3 is negative 1, plus 4 is 3, divided by 3 is positive 1, and I have 0 indeed. Now, as soon as you have only a second degree remainder of these successive synthetic division, you can conclude, okay, because you know how to factor these. So I will have that f of x equals x plus 1 times x minus 2 times x plus 2 times x minus 1/3 times 3x squared minus 3x plus 3. And I'm going to go one step further to have fully f of x fully factors, is that I'm going to factor out the 3 there. I'm going to put that in front. And I'll have x squared minus x plus 1, which is a prime. And not only that, but as we are going to see, it is it doesn't have any real solution. So I will have either completing the square or using the quadratic formula. So now to find the zeros, the roots, I'm going to solve f of x equals 0. Based on the work that I did, I can directly conclude that x equals -1, or x equals 2, or x equals -2, or x equals 1/3. Or, since I want all the complex roots, which includes the real ones, but also the purely imaginary ones, that means that x squared minus x plus 1 equals 0. So I'm going to calculate the discriminant, b squared minus 4ac, which is -1 squared minus 4 times 1 times 1, and I will get -3. Now, the square root of this discriminant will be I square root of 3. Therefore, x will be equal to -b, which is -1, positive 1, plus or minus I square root of 3, divided by twice a twice 1, which is 2. And here we go.